Hello? A week ago, I participated in stage 17 Jinan or Jinan of second Universal Cup, and there was this problem. I spent quite some time on this problem, but maybe I chose a bit wrong approach, so I'll try now my best to solve it. The problem is deceptively easy. You're given two straight line segments on a 2D plane, and we pick uniformly at random a point on each of them and calculate the distance between these points. And we need to find the expected value of this length. And this is what is needed here. We need to calculate this expected value, and we need to do it quite with a high quality, high precision. So the first several minutes will be dedicated to trying to find the formula. And I will search for the answer in this form. So assume that we have an angle alpha. Also, I choose 2 points here. Not 2 points, but... well, yeah, 2 points actually. And then let's call this distance x and this distance y. I need to find the distance xy, and I want to find it for x from 0 to a on average and for y from 0 to b on average. Okay, what is the length of this segment? Actually, it's simply the size of this vector. Yeah, so let's call this point x and this point y. Then this is square root of xy squared, which is... oh, sorry, this is y and this is x, which is square root of what? Of inner product of xy and xy. Now let's rewrite it as sum of xo and oy, or simpler oy minus ox. Okay, now we can simplify it, because okay, let's find a unit vector here which is OA and unit vector here which is OB. And then it is OY is YOB minus XOA. And again YOB minus XOA. Now let's apply distributivity. Now we have YOB minus 2 times YOB XOA and plus XOA XOA. dy dx. Now let's notice that since these two vectors are co-directed, then, and this is a unit vector and this is a unit vector, then this is simply y squared. So here we have y squared. Okay, what is this? So this is minus 2xy times the cosine of alpha. And finally plus x squared dy dx. So it would be really easy if only cos alpha was 0, but this is not the case. Or 1. 1 is better, not 0, 1. But this is not the case. Cos alpha can be anything between minus 1 and 1. So we have a problem. Let's continue. So what can we do here? What can we do here? Well, basically, let's look at this expression Hmm. 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 I think I want to try something. I think I want to try something. Let's say that we have capital X, which is x squared, and capital Y, which is y squared. Can we do it? Oh, you know what? I don't like it. No, let's not do it. Maybe it's fine. But no. No, I don't think so. Okay, for now, let's try and fix x, for example. Yeah, let's fix x. For a fixed x, it is a square root of a quadratic polynomial. Okay, how to calculate it? Okay, to do that, let's start with several simple observations. So first of all, we would like, instead of y, so we want to not have here any sort of this term. Let's eliminate it. To eliminate it, let's say that y is actually z plus x cos alpha. So here we have minus x cos alpha. Here we have x cos alpha. Let's write here that z equals y minus x cos alpha, and y is z plus x cos alpha, and actually dy, given a fixed x, dy is just dz. So now here we have z squared plus 2xz cos alpha plus x squared cos alpha cos square alpha minus z times 2x cos alpha minus 2x squared cos square alpha plus x squared dz dx. Minus x cos alpha b minus x cos alpha. Okay. Interesting part is that here this and this annihilate, and this almost annihilate. So now we have z squared plus x squared times 1 minus cos square alpha. Okay, let's continue. What can we do here? Basically, Yeah, basically we can say that this is z squared plus x squared sine squared alpha. So maybe we would like to say that z squared is so we could say that z is t sine alpha. And t is z over sine alpha. So now instead of this thing, we have, so t is z over sine alpha. So we have here tan alpha, and here we have b over sine alpha minus x tan alpha. Okay, let's look here. Instead of z squared, we have t squared sine squared alpha minus plus x squared sine squared alpha. And dz is, note that I don't differentiate sine alpha, of course, because it is not a variable. So we have sine alpha dt dx. Let's move on. Now I can eliminate. Actually, I was wrong. I was wrong. No, it's not how you do it. We need to say that z is xt sine alpha. So now it's an integral from so I need to divide by x sine alpha, so it's now minus cotangent alpha, and here b over x sine alpha minus cotangent alpha. Okay, here now we have x squared t squared sine squared alpha plus x squared sine alpha squared x over sine. No. Again, I was wrong, because it should be z over x. Yes. X sine alpha dt dx and what? Look, so here, again, the same integral. Now I can remove x squared sine squared alpha from under this square root, so I have Actually, let's assume that alpha is from 0 to pi, because why not? And if so, then sine alpha is greater than 0. Okay, so we can take this root, and we have here t squared plus 1 x sine alpha dt dx, which is simply integral x squared sine alpha squared times integral from minus cotangent tangent alpha to b over x sine alpha minus cotangent alpha. Okay, let's go on. Here we have square root of t squared plus 1 dt. Okay, to do it we need to find antiderivative of t squared plus 1, and I have already done it during the contest. Let's redo it again as fast as possible. So we know that when we see an integral like this, instead of t we want a hyperbolic sign. So let's say that t is hyperbolic sine of s, and dt is hyperbolic cosine s ds. Then we have an integral of sh squared s plus 1 ch s ds. Yes. Let's continue. So okay, this is ch, so now I have an integral of ch squared s ds, and now I need to eliminate all sorts of hyperbolic functions. Instead of that I want just exponents. So this is e to s plus 2 plus e minus 2s over 4 ds, which is simply e to s minus e minus 2s over 8 plus s over 2. But then this is not the end, because we want to express it in terms of t. So let's find t if we know s. So we know that t equals shs. So we know that es minus e minus s over 2 is t. Then we know that e to s minus 2 t e s minus 1 equals 0. And then we can calculate es, which is t plus square root of t squared plus 1. extraordinary. Also, we can calculate e to the power minus s, which is simply square root of t squared plus 1 minus t. Okay, having that in mind, let's calculate e to the power 2s, and it is t, let's do it on a new line. So it is t squared plus 1 plus t squared plus 2t root. Okay, then again minus this is the most important thing, yeah, 2t root of t squared plus 1. After that, minus the square of this thing, of the lower thing. So again, it is minus t squared minus 1, and again plus 2t square root of t squared plus 1 over 8. And plus s over 2. And s is easily a logarithm of t plus square root of t squared plus 1. Okay. Okay, what is that? This is simply t square root of t squared plus 1 over 2 plus logarithm of t plus square root of t squared plus 1 over 2. And this, it looks like a final answer. But you can never be sure, so let's differentiate it. d dt of this equals, so square root of t squared plus 1 plus t times t squared plus 1 2 times 2t plus 1 over t plus square root of t squared plus 1 times 1 plus this again. So 2 square roots of t squared plus 1 times 2t. Okay, let's simplify this. So I see square roots of t squared plus 1 everywhere, so let's put it in the common denominator. Okay, so first of all, this becomes simply t squared plus 1. This becomes t squared. Then this becomes t squared plus 1 minus t times 2t, not 2t, but t. T squared plus 1 plus t. And now we can easily see that it is 1, it is just 1. So this is t squared plus 1 times 2 over 2 square root of t squared plus 1, which is square root of t squared plus 1. Excellent. So we have calculated the antiderivative. And it has this form. Let's continue. So now let's rewrite what I had. I had from 0 to a integral of what? Of x squared sine square alpha times integral from minus cotangent tangent to b over x sine alpha minus cotangent of alpha of square root of t squared plus 1 dt dx. Great. Okay. Now let's substitute this into the formula. So we have something over 2. And so we have something minus something. Okay, the right side is, well, minus cotangent alpha times square root of cotangent square alpha plus 1 plus logarithm of minus cotangent plus square root of this. Okay. Yeah, this is understandable. But here we have something more messier, which is... Okay, let's rewrite it as difference of two fractions. Okay, the first fraction is b over x sine alpha minus cotangent alpha times square root of this square plus logarithm of something like this. Over 2. Okay, actually the second thing is just a constant. Yeah, so this is a constant. If I substitute minus cotangent alpha, it will become a constant. And since it is a constant, then it's kind of okay, because yes, this is some ugly expression, but it can be calculated, and then I can integrate it. It will be just x cubed times something. So this is the hardest thing. Actually, I can do it separately. Let's do it separately. X squared sine squared alpha times times not integral, but times fraction. 2 again, so here we have minus cotangent alpha times cotangent squared alpha plus 1 plus logarithm of b over x, not b over x, but minus cotangent alpha plus square root of cotangent square alpha plus 1. Sorry. Which is like a minus b. Let's calculate b firstly, because it seems fine. Okay, we have x squared sine squared alpha times. Okay, first of all, let's make a subroutine which calculates square root of 1 plus cotangent alpha. Okay, this is square root of 1 plus cosine squared alpha times sine squared alpha, which is simply 1 over sine alpha. Okay. So this is 1 over sine. Yes. Okay, so b equals so cotangent. Okay, I will remove it. Minus cotangent alpha times 1 over sine alpha plus logarithm of minus cotangent alpha plus 1 over sine alpha over 2. Okay, here we have minus cosine alpha over sine squared alpha. Here it is interesting because we have 1 over sine alpha minus cotangent of alpha, and cotangent is cosine over sine. So actually we have here logarithm of 1 minus cosine alpha over sine alpha. Okay, it can be simplified. Yeah, because we know that cosine alpha is 1 minus cosine of alpha half squared. 2 times alpha. Correct? Maybe. Yeah, and here we have 2 times sine alpha over 2 cosine alpha over 2. So this is logarithm of tangent of alpha over 2. Ah, okay, now we can multiply by sine squared, actually. Okay, now let's also calculate this because I'm tired. So this is a cubed over 3 times, actually over 6. Now we have something here. times minus cosine alpha plus sine squared alpha times logarithm of tangent of alpha over 2. Okay, b is calculated when b is easy. The problem is with a, which is enormous. Which is enormous. Yes. Okay, we kind of have two separate addends. Let's work with them one at a time. So, first of all, we have x squared sine squared alpha times something over 2. B over x sine alpha minus cotangent alpha times square root of the same thing. Okay, so let's call this integral c and this integral d. So now we're calculating c. C equals what? Actually, that's it. Now let's simplify it. So let's start with one application. First of all, let's remove 1/2 from the integral. Let's apply it one time. Okay, then we just need to multiply this by x sine alpha, and it becomes b minus x cosine alpha. And then let's apply this the second time. Okay, what do we see in the square root? So this applies to this. And we again have b minus x cosine alpha squared plus x squared sine alpha squared. So what do we have now? When we simplify everything, so this becomes x squared. Then we have minus 2b cosine alpha x and plus b squared. Yeah, so actually it's the same integral as before. This time with this thing. Yes, this time with extra x cos alpha. Okay, this is a bit problematic because I just don't like it. That's enough. Well, let's go on. Well, it's two separate things. Okay. I believe we need to make the same thing as before. So let's say that now, for example, P equals x cos alpha minus B. Ah, no. No, it's not correct. Wow, it's definitely not correct. Okay, come again. So, again, I know what to do with B. The problem is I don't know what to do with x times this square root. So I think what we need actually, what we really need, is to calculate one more integral. Square root of t squared plus 1 times t. This is what we need. Ah, this is easy, yeah. This is really easy because this time I can say that I want to look at q equals t squared. Okay, so dt dq is 2t dt. So actually I have here square root of q plus 1, actually plus 1 here. So I have a square root of q, 1/2 dq, which is 1/3 q to the power 3/2, which is 1/3 of t squared plus 1 to the power 3/2. Is it correct? Let's recalculate. So 1/3 t squared plus 1 power 3 seconds prime equals 1/2 square root of t squared plus 1 times the derivative of this, which is 2t. Yes, this is kind of fine. Okay. So now we know this. Nice integral. We know this nice integral. Then let's continue. Okay, first of all, I really need to eliminate this thing. So I need to say that I want to look at P equals x minus b cos alpha, and so x is p plus p plus b cos alpha. So what do we have? So first of all, integral is now from minus b cos alpha to a minus b cos alpha. Then here we have b minus p cos alpha and minus b cos squared alpha times square root of p squared plus 2pb cos alpha plus b squared cos squared alpha minus 2p cos alpha x, no, not x, b minus 2b squared cos squared alpha plus b squared at dp. Okay. Okay, here we have b sine squared alpha minus p cosine alpha times the square root of what? P squared, and then this is I annihilating with this. This almost annihilates this, and we get plus b squared sine squared alpha. Okay, now we need to apply the same thing as usual. This is dp. We need to say the same thing. We need to say that now g is equal to what? G is equal to P over B sine alpha. And P is GB sine alpha. Okay. First of all, what about the integral? Since we now divide everything by B sine alpha, we get minus cotangent alpha and A over B sine alpha minus cotangent alpha. What do we get here? B sine squared alpha minus P cosine alpha. P cosine alpha, which is G B sine alpha cosine alpha. Okay. Then we have a square root of what? Of G squared B squared sine squared alpha plus B squared sine squared alpha. B sine alpha dg. Good. Now from here we get B sine alpha. Let's remove it. And here we get additional B sine alpha. Okay, so let's take them out of the integral. So inside we still have sine alpha minus G cosine alpha times square root of... No, we have... Actually, we have it 3 times. We have it 3 times. We have it 3 times because once we have it here, the second time we have it here, and the third time we have it here. So actually it's b cubed sine cubed. So again, I am eliminated it once. I eliminated it twice. And thrice. Yes. Let's go on. Let's go on. So I have sine alpha square root of g squared plus 1 minus g cosine alpha square root of g squared plus 1. Okay, this is the difference of two things, which we will be dealing with separately. Okay, first of all, this one. And this is easy because we just need to take this function here it is. We need to take this function and subtract it. So we need to take g square root of g squared plus 1 plus logarithm of g plus square root of g squared plus 1 over 2 double substitution of minus cotangent alpha and b over sine alpha, a over b sine alpha. Minus cotangent alpha. Okay. Minus everything here. So minus b cubed sine cubed alpha over 2. Actually times cosine alpha. And times integral of g square root of g squared plus 1, which is, as we know, 1/3 of t squared plus 1, 3/3. One third of g squared plus 1 to the power 3/3. 3 seconds. Also the same double substitution. Okay. Finally, we also need to calculate d. D is, if you still remember, this part of the integral. So let's copy this integral. And then I will calculate d. So we have integral from 0 to a x squared sine squared alpha times logarithm of b over x sine alpha minus cotangent alpha plus square root of b over x sine alpha minus cotangent alpha squared plus 1. This is our last integral. If we solve it, we will be happy. Okay, as we know, logarithm of anything, of any ratio, is difference of two logarithms. So let's say that I have logarithm of this thing times x sine alpha, and then minus logarithm x and minus logarithm sine alpha. So first of all, let's multiply everything here but x sine alpha by x sine alpha. And minus logarithm x minus logarithm sine alpha. Let's go on. Okay, let's simplify it. First of all, this logarithm of b minus x cosine alpha plus b squared minus 2b cosine alpha x plus x squared. Okay, minus logarithm x minus logarithm sine alpha. Okay, this is again, it feels like we don't need so many different things here in our solution. So let's eliminate them. First of all, this one. This is definitely just a cubed over 6 sine squared alpha logarithm sine alpha minus this. Okay, now this one. This also should be easy. Yeah, so how do you integrate x squared logarithm x? Let's learn how to do it. Yeah, so let's start with integral of just logarithm x. And it is done via partial integration. So I say that it is 1 times logarithm x. And this is x log x minus integral of x times 1 over x, which is x log x minus x. Okay. It should be even easier with x to the power alpha log x. Not alpha, let's say k. It is x to the power 1 over k plus 1 times x to the power x plus 1 log x minus integral of x to the power k over k plus 1, which is simply k plus 1 squared. Okay, let's substitute k equals 0. When k equals 0, it becomes, yes. Let's also differentiate it. So d dot dt dx equals what? So k plus 1 x to the power k times k plus 1 log x minus 1 plus x to the power k plus 1 times k plus 1 over x. Yeah? Okay, this is x to the power k times k plus 1 log x minus 1 minus k to the power x to the power k over k plus 1. And now these cancel out and we are left with just xk log x. Okay, nice. Nice, nice, nice. We have this formula, beautiful formula. So green thing is what? So green thing is sine squared over 2 minus sine squared over 2. Then we have x cubed times 3 log x minus 1 over 9 in 0 and in a. Actually, I don't like it when we... What? Ah, x log x. Yeah, it's fine. X log x approaches 0. It's not minus infinity. So when x equals 0, it's just 0. So we need to just substitute it into it a, and we get minus sine squared alpha a cube 3 log a minus 1. Okay. So this is our thing. And we're left with the main addend. Let's rewrite it. X squared sine squared alpha over 2 times logarithm of b minus x cos alpha plus square root of b squared minus 2b cos alpha x plus x squared. This is not good. This is not good. This is not good. This is definitely very bad. So the question is there any sort of way to say that this is someone's logarithm? So this is someone's exponent. Let's try, I think, because otherwise it's frustrating. Let's see. So we have b minus x cos alpha plus square root is someone's square. So this is not square, but for example, it's like c. Okay, now we can say that b squared minus 2b cos alpha x plus x squared is c plus x cos alpha minus b. And we can take square. So b squared, no, let's keep orange. B squared minus 2b cos alpha x plus x squared equals, okay, b squared plus x squared cos squared alpha minus 2bx cos alpha minus bc plus xc cos alpha and 2 somewhere, and plus c squared. Okay, now we remove b squared, and actually we also remove 2b cos alpha x. But we don't remove x squared. Ah, okay, this is fine. Let's move everything to the left side, and we get x squared sine squared alpha plus... Ah, we can calculate x. Let's try and calculate x maybe. Minus 2xc cos alpha plus 2bc minus c squared equals 0. Okay, now let's calculate x. X equals 1 over sine squared alpha to, not 2, c cos alpha plus square root of c squared cos squared alpha minus 2bc sine squared alpha plus c squared sine squared alpha. Okay. Okay, c squared cos alpha plus c squared sine alpha is just c squared. And we have minus 2b c sine squared alpha. Good. So let's write like this. Square root of c times square root of c cos alpha plus square root of c minus 2b sine squared alpha over sine squared alpha. Okay, actually, it would be lovely. So let's take d equals square root of c over sine alpha. And we get d times d times tangent alpha plus square root of no, not tangent, cosine alpha. D squared minus 2b. Okay, so just a moment. Well, Mm-hmm. Okay, so if we do it, we have. God. So the idea is, let's take all this this whole expression and say that this is C. This is C. Okay, whatever. So now we have the following integral. We have integral from 0 to, not from 0 to a, but now from this to this. Okay, let's substitute 0. If we substitute 0, it becomes 2b. So this is integral. Ah, it's c. Okay. So if I substitute 0, so c is 2b. However, here I need to take root and divide by sine alpha. So I get square root of 2b over sine alpha. Okay, let's substitute now a. And it becomes something. It becomes something terrible, which is square root of what? Of b minus a cos alpha plus square root of b squared minus 2ab cos alpha plus a squared. Over sine alpha. Okay. And among all of this, we multiply by logarithm no, not by logarithm. Ah, yeah, by logarithm. So first of all, we have x squared sine squared over 2. So x squared becomes, oh my god, x squared. Ah, x squared becomes this thing squared. Do I really want? Maybe I just want c because it becomes squared. Yeah, I think I want c. I don't want d. Yeah, let's take c. Okay, so here I just have 2b. Here I just have this. So I need to multiply x by sine and take square. So let's multiply x by sine and take square. So we have c over 2 sine squared alpha times square root of c cos alpha plus c minus 2b sine alpha squared times logarithm of c and times dx. So instead of this, let's write dx in terms of c. So I need to take the derivative of this expression. Oh, but it is ugly. But who cares? So this is cos alpha over sin squared alpha and plus the derivative of this thing. Okay, let's calculate the derivative of this thing. 2 square roots of ac squared minus 2bc sine squared alpha times the derivative of what's inside. And inside we have 2c minus 2b sine squared alpha. Now we can divide it by 2. Let's divide it by 2. That's it. Yeah, that's basically it. So here we have cos alpha sin squared alpha plus c minus b sine squared alpha over square root of c squared minus 2bc sine squared alpha. dc. Okay, this is awful. This is really not good. I hate it. I don't like it. Let's try and simplify it at least somehow. Okay, so first of all, 1 over 2 sine squared alpha is here. It's okay. We can remove it. Times integral of c squared cos squared alpha plus 2 c cos alpha square root of c squared minus 2bc sine or sine squared alpha? What? Sine squared alpha, always. Plus c squared minus 2bc sine squared alpha. plus or minus? Are we sure that it's plus here and not minus? Why did I put here plus? I don't know. Ah, we know that x is positive. We know that x is positive. However, it's still unclear. Yeah, it's not very clear. Okay, let's hope for the best. And let's assume that it was fine to put. It was fine to put 0 here. Oh, not 0, but what? To take plus here. Well, it's not always good. Yes, because maybe I need to take minus. Well, how can I know? If x is huge, then it might be plus. We don't know. Maybe it's a wrong approach to do it. Yeah, it was not good to do it. Okay, let's for now forget about it. Let's do it the usual way. So I say h equals x minus b cos alpha. So we have here h plus b cos alpha squared sine squared alpha over 2 logarithm times logarithm of what? Of b minus h cos alpha minus plus minus. Okay, so we have b sine squared alpha minus h cos alpha plus b squared sine squared alpha plus h squared. Okay. Okay, great. Great. Extraordinary. As always, let's now say that it is so r equals h over b sine alpha and BH equals RB sine alpha. Now we have B sine squared alpha minus RB sine alpha cosine alpha plus square root of B squared sine squared alpha plus R squared B squared sine squared alpha, which is equal to sine alpha, b sine alpha times sine alpha minus r cosine alpha plus square root of r squared plus 1. Okay, so let's state again what we have. So now we have integral. So initially it was from 0 to a. Then we subtracted b cosine alpha. And after that we divided by b sine alpha. So here we have minus cotangent alpha, and here we have b a over b sine alpha minus cotangent alpha. What do we have here now? So h is now rb sine alpha. So we have rb sine alpha minus plus b cos alpha squared over 2 plus, not minus, plus b cos alpha squared times sine squared alpha and also we need to multiply by dx, which is now dx is dh and dh is dr b sine alpha. So we need to multiply by b sine alpha. Okay. And all of this should be multiplied by a logarithm of something. by actually by logarithm of b sine alpha plus logarithm of this. It's not good. No, it's not good. So now we have something like, okay, I'm so tired that I might start using Wolfram. Okay, is it even possible to do? So first of all, let's integral of what? So we have something like sine RA times sine A minus cosine A times x plus square root of z plus 1 and logarithm of this. So is it possible? Ah, it is possible. Okay, not only that, we also need the same thing for r squared and r. And it should be also possible. Who would think that it is possible? What? It doesn't? Oh. That's so beautiful. Oh my god. Oh my god. Okay. See, it is possible. And I even would be able to calculate it, but I'm so tired. We also need to implement this. So let's deal with it. I calculated everything but this formula, and I will just use it. Okay? So we actually only use some very simple functions like logarithms, some tangents, etc. So not much is needed now, actually. Not much is needed. Okay, let's go. We will need a lot. We will need a lot of all sorts of some formulae. Actually, we also didn't consider the case of parallel segments, and I'm afraid that we don't want to do it. Because really, I'm not sure that we really want to do it. Hmm. We need to read 8 integers. Okay, let's make reading. Mm-hmm. Okay. Okay. So what do we do? What do we do? Well, we need. So let's write a function which calculates. Oh my god. Let's calculate a function which calculates this integral. Okay? So let's call it somehow. It's like plot find integral. So what do we take here? We take a, b, and what? And cosine alpha. Find the integral given a, b, and cosine alpha. Or maybe even just alpha, I think. I think it's fine to just take alpha, or not. I don't know. Okay, let's now find answer. How do we find answer? Not very hard. To find answer, we need to take our two segments. We need to take their intersection point. And let's start with it. How do we find the intersection point? So we have a1, b1 and a2, b2. What I actually want, I actually even don't want the intersection point. I want such numbers. I want such numbers k and l that this is the intersection point. So what I want to take? I want to take. So let's call it v1 and let's call it v2. So I want to find such numbers k and l that a1 minus v1 times k equals a2 minus v2 times l. Okay, let's rotate. Let's call the rotation r. Let's multiply both sides by r of v1. So now we have a1 times r of a1 times r of b1 minus a1 minus v1 times r of v1 times k equals r of v1 times a2 minus r of v1 times v2 times l. Let's go. So this is simply 0. Do we get a1 times R of V1 actually, I just need to calculate L. Yeah, I just need to calculate L, and it's easy. L is simply R of V1 times V2 and here we have R of V1 times A2 minus A1, and it can be rewritten as V1 times A2 minus A1, and here V1 times V2. Okay? Okay. So let's take L equals what? L equals let's find V1 and V2. And I believe that we can find K by replacing V1 with V2 and V2 with V1. Yes? And G and H. Okay, now we have K and L, and what we need to do is to apply this function 4 times. So we need to find. Okay, we need to find lengths also. Let's find lengths. We need to find some integral and divide it by L1 times L2. What do we do here? We need to find integral. Also, we need cosine alpha. So we need to find 4 integrals. So integral yeah, so we need to find integral of AL cos alpha. Let's just find 4 integrals. Okay. So now we only need to find the integral. Okay, as we know, this nice huge integral is simply c my... What? Ah, a minus b. Okay, so we need to find float a and b. Then we say that float c equals something, float d equals something, and float a equals c plus t. Actually, I think we also want sine alpha. Okay, we find is C plus D. What answer A is A plus A minus B. And return answer. So we need to find C and D. And B. Okay, and I do it here in the following form. So I say that B equals A. B equals A cubed over 6 times minus cos alpha plus sine alpha times sine alpha times logarithm of tangent of alpha over 2, which is 1 minus cos over sin. Okay, we found B. Now we need to find C and D. Okay, C is definitely C1 minus C2. So we need to find C1 and C2. Okay. Then let's make auto calc C1 equals a lambda, and inside this lambda we return kc times something over 2. Here we have x times square root of x times x plus 1 plus logarithm of x plus square root of x times x plus 1. Okay. Okay, this is calc C1. Also, we need calc C2. And here we need 1 over 3 times power of x times x plus 1 1.5. Great. Also, let's say plot x c up equals a over b times sin alpha. A minus b times cos alpha. And xc down is just minus cos alpha over sin alpha. So float c1 is calc c1 of xc up minus calc c1 of xc down. And the same for c2. Now we need to only calculate d. Everything else is ready. Unfortunately, it's as always, it's awful. We can say that d is d1 minus d2 minus d3. Let's again calculate d1, d2, and d3. So d2 is a cube times sin alpha times logarithm of sin alpha. Also, we have d3 equals sin alpha times sin alpha. Again times a cube. Times three times logarithm of a minus 1. Actually, just in case if a is 0, exactly 0, let's add something like this. Okay, and now we need to calculate d1. Unfortunately. But unfortunately, it's the end. We only need to calculate this ugly d1. Okay, so we have this type of integral. Integral from something to something of what? Of r to the power k times coefficient times We also have this. Yeah, which is easy. Times logarithm of sine alpha minus r cosine alpha plus square root of r squared plus 1. Okay, we have this type of integral. Okay, d1 is actually dc plus d1 plus dc plus d I0 plus d I1 plus d I2. Let's do it. So first of all, dc. For dc equals what? Equals okay, plot, let's make xt down equals xc down xt up equals xc up. Then dc equals calc dc of up xt up minus calc dc of xt down. And then we have this di0, I1, E, and A2. And we need to write these four functions, but they should be easy. Okay, first integral. Yeah, this is simply okay, I will just add it to integral. I don't want to do it this way. So let's just add a logarithm of b sine alpha. Sine a. Why did you do it? Unfortunately, it made it worse. Oh. Okay, whatever. we need to return -1/72 times sine cube times something. Oh, what? So how can I calculate sine of 3 alpha? Okay, let me just call it A and B, because I don't want it. So A is sine alpha, B is cosine alpha. Why are you doing it? Why do you use I here? Okay, it cannot do it without. Whatever. Why? I just replaced A with... Ah, because it should be alpha, yeah. Okay, we need cos of 2 alpha equals... What? Sin 2 alpha equals 2 times sin alpha times cos alpha. What? Sin 3 alpha equals sin alpha transpose to alpha plus sin to alpha transpose alpha. Again, we need something terrible. again, I am calculating some strange log too many times. Okay, nice. This was GI2. Okay, I have written it. Everything is done. We only need it to get accepted on at least some test. Okay, here it will be division by 0, I believe. The first one is division by 0. Oh, yeah. None, none, and none. Okay, maybe they are all parallel. But I think no. Okay, this is a horizontal segment. This is a horizontal segment. Okay, I understand. But for example, these two, they're not parallel. They are perpendicular. So let's look into them. Okay. First of all, actually I want to solve the problem when they are parallel, because why not? Okay, when they are parallel, actually the problem is parameterized, but by not many numbers. First of all, it's the distance between two lines on which these two segments lie. And secondly, the length. So, okay, let's assume that this is 0. This is A. No, this is A. This is B. And this is C. Yeah, so we have the following integral. integral from 0 to a and from 0 to b. C plus y minus x squared plus h squared dx dy. Okay, if we do it like this, then we have the integral from 0 to a, and then actually instead of x we can consider this is y, this is x. We can consider the integral where it is y, z is y minus x, or alternatively y is x plus z. So now the inner integral is from zero to, not zero, but minus x to b minus x. And now we have square root of c plus z squared plus h squared. Now we can swap the integrals. So minimum possible number here is minus a, maximum possible number here is b, and then the second integral is from 0 so so we know that 0 is y minus x. We know that x is y minus z. Okay, we know that z is between x and b minus x. So we know that x is between minus x and b minus x. So x is between minus z, b minus z. But also it is at least 0, so we can put here minimum maximum of 0 and minus z, and here minimum of b minus z and b. Okay, now this integral does not affect anything except the length of the interval, so we can replace it with this. Okay. Actually, it is b minus z over 2 minus modulus of z over 2. And this is minus z over 2 minus modulus plus z over 2 minus modulus z over 2. Yeah? Yeah, so if z is positive, it is 0, and if z is negative, this is minus z. No, if z is negative, it is z. So this is b minus modulus z. Okay. How do we calculate it? We replace it with two integrals. Yeah, we say that it is integral from c minus a to c of these. Okay, first of all, No matter what? Why is it asymmetric? Why is it B here but not A? What happened? Ah, it should be A here. Okay. Hmm. Okay, so what do we do here? We have a segment from C minus A to C minus B. On this segment, we possibly add points B plus C minus A over 2 somewhere here, and just C over 2 somewhere here. We somewhere add these points. After that, we have 1, 2, or 3 segments. On each of them, this function is a linear function. And since it is a linear function, it can be calculated. So again, how do we calculate integral from a to b of k t plus l times square root of t squared plus h squared? We say that these are two separate integrals. Kt square root of t squared plus h squared plus L square root of t squared plus h squared. After that, the first of them is simply k over 2 square root of s squared plus h squared s plus h squared which is okay. And this thing, the second one, we say that we want q equals t over h, and then t equals hq and dt equals h dq. So we have L square root of h squared q squared plus h squared times dt, which is h dq. And then it is L h squared times square root of q squared plus 1q plus log of q plus square root of q squared plus 1. And then we need to replace back q with... Okay, we can leave it like this, but we need to put there a over h and b over h. Okay, let's go. So if v1% v2 equals 0, then we need to make a parallel integral So, which parameters do we need? We need several parameters. We need A, B, C, H. Okay? So A is simply the length of the first segment. Okay. B is the length. Actually, let's put it like this. Okay, if v1 times v2 is less than 0, let's swap v2. So v2 equals minus v2 dot x minus v2 dot y, and h a swap h dot a and h dot b. Okay, after that, find parallel integral a, b. Okay, then c. What is c? C is this time this unit vector. So it can be calculated as h dot a minus g dot a times v1 divided by l1. Okay, this is c. And finally h, and h is the same thing but with percent and with arcs. Okay, let's write this function. Okay. Okay, okay. Mm. Yeah, let's make it simple. Let's make a vector float. Let's put there let's put there a c minus a, c plus b, c over 2, and c plus b minus a over 2. Okay, then let's sort. And let's go through this array. Okay, so we need to check. No, not parallel integral, but parallel integral divided by b minus a. Parallel integral divided by a and b. Yeah. By L1 and L2. Okay. So I need to integrate from a to b. I need to integrate from minus a to plus b. A and b are always positive, aren't they? Are a and b always positive? So a and b are here, and yes, a and b are always positive. Okay, this is very good. Actually, this is very good. Okay, the next thing is to present it in this form. Present this integral in this form. So we have like float ans equals 0. In the end we return ans, and ans plus equals find linear parallel integral of some form. So we need to put there a, b, k, l, h. A, b, k, l, h. Okay, h is same always. Now we need to calculate a, b, k, l. So from where to where? So a and b is easier as l and r. Now k and l. We need to calculate linear term and free term. So first of all, okay, let's call them k and b. Let's start with these. So a plus b over 2 is b. A plus b over 2. Yeah. Okay, next is this one. So we need to take the middle of this segment, which is, okay, a minus b minus c plus t. What is t? T is L plus R over R from over 2. So if this is at least 0, then this means that this modulus is opened without the sign change. So I need to subtract a minus b minus c over 2. Okay. And linear term is minus 1/2. And also if t minus else I do the opposite. Okay, and also if t minus c is at least 0, then also constant, not t but L plus R over 2, constant plus equals C over 2 and K minus equals to 5. Else minus and plus. Okay, and then we need to find parallel integral. Okay, let's go. It is a linear part becomes K over 3 times okay, constant part becomes L times h squared times something over 2 b over h. What if h is 0? Also h can be 0. Yes? What if h is 0? Okay, if h is 0, then this is simply absolute value of t. Let's add 0 here. So we have one more case if h is 0 and something. If h is 0, then this is integral from a to b, kt plus l times absolute value of t. So we need to check. So it is like ut where u is 1 or minus 1. Yes, so u equals a plus b over 2 greater than 0, 1 or minus 1. So this is float u. And then we have kut plus lu from a to b. So this is kub squared minus a squared over 2 plus lub minus a. Return u times something. U times b minus a, actually. Times L plus K times A plus B over 2. Okay, let's continue. So B minus A plus logarithm of the same thing. Okay, we have solved at least one case. Still, I think it will be incorrect. Okay, it is 0 and 3 is 0 now. Which is still very bad. But nonetheless. Ah, because we need here these two guys. Okay, now it's negative. I'm just so tired of this. Ah, I wasn't correct. I wasn't correct. It is t here, and this is t squared. So it should be squares here and cubes here. Okay, now it's better, but that next case is bad. Okay, now this is fine, and now we only need to fix this one, which is still unfortunately not correct. Why do we divide by b? We shouldn't divide by b is 0? No, it's not okay. Why is b 0? Okay, now it's positive, but it's not correct. Okay, a also can be negative, unfortunately. Why am I taking a logarithm of a if it can be negative? Okay, we assume that a is positive, I think. Okay, for example, if a is negative, we can return find the integral of minus a b, but in this case, cosine alpha will be minus cosine alpha. And likewise, if b, then this. Okay, I think we will need Wolfram to do it. I think we will need Wolfram to do it. Because it's just madness. Okay, let's start with this one. What do you need? Are you kidding me? Hmm. I don't know how to find the error. Okay, let me just do it a bit later. Thank you for watching, and stay tuned for the next 4 hours of solving this problem.